Today we will start on another topic, that is pointer. Okay, so we'll discuss about all this topic. Okay, I will suggest you to see whole video. Why I'm saying it? Because in between of a video I sometimes tell some tips which is very important to that topic. Likewise, if you see this one, no, this some of the tricky thing, okay, in pointer, and this one, okay. So for pointer, we have to understand two things, okay, that is and this is similar to all other languages. When you have studied C or C++, you will see this same thing here, okay. So what this means is that address of, okay, int var int val int, let me put it like this one, okay, and I have put it one, okay, and then this, and I put it something like this, int val. And what I do is that I tell that this is address location, okay. For your convenience I will just make it a variable, okay, and I will tell this is a pointer int, okay, and then I will try to print it, print j, okay. So what you will see that it's the j value will become 1, okay. Okay, so let's see what's happening behind the scene, okay. I will just copy this one and I will edit here, okay. So what is happening actually, so let me pick up draw, okay. So let's say this is a memory, okay, RAM, okay. So RAM you already know, it's a memory. So in memory we have multiple blocks, okay, and each block signifies an address location, okay. And now when I'm saying this thing, so it is saving somewhere in the memory location like this one, and let's say this memory location is 1 2 3 4, okay. So let's signify here, so I and T, well, okay, my drawing is very worst, okay, and it has a value this one, but it is saving inside a memory location 1 2 3 2 3 4, okay. So when we are writing the second line, no, this second line, so what we are telling to the j is that this j, again the j have also, j is also, because it's a variable, j will be also having a memory location 3 5. Let's say j is store here, j is save here, okay. And when we are saying assign address int val to it, so what we are saying that uh, as for this pointer the value is the address of this one, x 0 1 2 3 4, okay. So when we are printing in the j, so what we are telling, so when we are saying asterisk j, so asterisk j means that we will be printing uh, value of their address location, okay. So what we are doing when we are saying print asterisk j, we are saying print the value of this address location, okay, this address location. So that means it will print I, okay, you got me. So so this is the way how it represents in the memory. So let's see what other topic we have. Okay, so we'll go with this topic first. Okay, so where pointers should be used. Okay, so it's like so here if you see I and j in a function, this is just for understanding, your understanding. Okay, so we should not use in simple scenario like this thing. Okay, so one of the major thing where this is used is that, let's say you are processing some bigger svc, some file. Okay, so what you are doing, you are reading some files. Okay, which has 10,000 records or 1 million record or 10 million record, anything, or you are processing big data. Okay, and what you did is that, you know, you have one structure. Okay, let me create a structure. Mm, type. Mhm. Okay, and then in that values are names, name, uh, roll number, int. This way there are multiple things. Okay, and let's take an example on this one. Okay, so and what you are doing is that, you did some processing here. Okay, you did some file processing here, file processing here. Okay, then from that you created a structure that is called person. Person detail. Let me make it more generic name, person. Okay, and here what I can do, person name, Tom, roll number 1. Okay, so let's this same 10,000 records are stored in the person detail. Okay, and I create another function, that is function data process, and I say, okay, what I need here is that structure. I will just define person detail only, and what I can do is person. So you can pass array. Okay, and you can create array of it, and you can pass array of it. Okay. So what you will see here now, what we do is that, so if we pass this value here, and it, let's say this has 10,000 records. Okay, and you pass it here, so this will pass as a value. So what will happen is that it will create a copy. So if it has 10,000 record, it will create another copy on a variable that is 20,000 record. Okay, this way, if let's say you are working on a program and which is 1 million record, it has the structure has, when you are doing some data processing. Okay, on that way, that when you are passing it here, okay, it will get 2 million records, but it should be 1 million records only when it is 1 million. Okay, this way what we use pointer. Okay, and we pass an address of that pointer. So instead of creating records of uh, person, so you see, so this is what it will do. Instead of creating duplicate data into another variable, it will just pass the address location of that. Okay, that is one of the major advantage of pointer. Let me show you the example of structure only, how structure is used for the pointer. So we are here only. So meanwhile, what I will do, I will so here what is the person name is, that person name is Tom. Okay, what I will do is that I will change here person detail. Okay, detail dot name, Harry. Okay, then here what I can do, I can just do fmt dot print, and here I do percentage. Okay. So what you will see is that it will change, the here percent detail will be automatically changed. Okay, but because of pointer we are using, that's why it is getting changed. Okay, you see Harry one. Okay, so if we would have not used this here, okay, and we would have just passed person, you would see that it will just print on, because it is passed by value, so it is just copying all value here. Okay, got me? But now there is another topic on this one. Okay, but there are some data types which are by default reference type data types. Okay, usually what you will see is that there are two types of data types in the Golang. Okay, like with this int, string, and everything. Or these are all the basic data type. So they are just passed by value. So if you pass them, data will be copied. Okay, but there are certain data types which are only custom data types, are those which are passed by value. So one of them is that map, slice. Okay, so these two are the passed by reference. Okay, a structure is passed by value, that's why it's not replicating. Okay, let me give you example of map. Okay, so I will not use a pointer for map, but it will change the value. Okay, map. So I'm just creating a map which holds string. I will just pass name, Tom, and person detail. We'll just remove this one, we don't need this one. And then here I need map string. Okay, then what needs is name. Okay, let him print this one. Now I have not used pointer, but still it will change it. Okay, okay, you see it's changed. uh, let's show something to you actually. Okay, so if you see here, so when we were talking about data types, so you will see, so go basic data type, you will see all the basic data types, also basic data types are passed by value, so the value will be passed. Okay, and you see for the composite type, you will see that for reference type, so if you are using slice, channel, map, pointer, or function, they are by default they are passed by reference. Okay, you don't need pointer for this data type if you are using. Okay, okay, let's start with the new another topic on this one. So this is, if you don't want to understand, it's fine. If you don't understand, it is out of the pointer, but it's a little deeper pointer how in memory it is working. Okay, so we will talk about memory stack and how it is working. So you already know in previous topics we discussed about Go routine. So if this main is there, so main is a thread itself. So this is itself a Go routine. Okay, so what happens in memory? Okay, let me clear this up. Okay, okay, so what we are talking about, so we are talking about this one. Okay, so let's talk about this code base. Okay, so what is happening beneath? Okay. Okay, so what is happening? So when this code is there, so if I take this one, so what is happening? So this is main. So it will generate a go routine, okay, and it will create by default, you know that in all the applications it create a stack, okay. In that stack, what it has done, it has, once I'm on starting of the application, it calls main, okay. So it has main. So what happens that in that, so let me take an example of a structure instead of it. Let me do Control Z instead of map, okay. So I will just copy this one. Okay, let's see this thing. So now we have used structure. So what is happening in this one? We'll take blue one. So here, so when we are doing it, so one more value is there, which is this person detail, okay, person detail, okay. And when we are passing this person detail here, so what happens here is that in a stack, a new this creates, and here we do is data process, okay. Okay, so instead of passing that main, okay, what we do is this person data, what we do, we pass its address, okay. So here what we'll see, we pass address, okay. So that is what happens, okay. And once this is executed, so this will automatically go out of memory, okay. It will clean up from the memory, and then next thing happen. So this is the way how different functions and this pointers works, okay. It pass address, okay. So but what happens, one issue is here, okay. So if we do something like this, okay, let me take one other example. So I create a structure inside here, okay, and I don't need here this one, okay. This is not needed, okay. And here is one person, and this one, okay, and define, yeah. So what it is doing is that it is just calling data process. Inside the data process, we are creating a structure, and just we are returning a structure to this one, okay. But let's print this one, okay. So you will see Harry is printed, okay. So but what you see is that here what happens, that we saw in the diagram here, okay. So once this operation is done, okay, this will come out from the stack, okay. Now there is no location, okay. So for this code base, if we go here, if we go here and we copy paste this code base here, okay. Okay, so what happens this one, because what let me create a diagram quick, very fast, okay. So this is go routine, okay, go 15. Okay, in that main comes. Okay, and then when we do data process, the data process goes here. Okay, so what happens, but when we do this one, okay, so this task is completed, but how again we are able to print here the value, because once the task is done, this will go out from the stack, so we don't have anything here. Okay, but what happens instead of it, if something like this is there? Okay, so what do Golang do is that there is something called heap. Okay, so if something this type of happening, so instead of creating values here, okay, so this will create a value here, person detail, a variable name like this. Okay, so but what happens with this type of issues, that heap, then the garbage collector has to clean the memory. Okay, so so it's recommended to not use pointers where it is not needed. Okay, yeah, this is all about pointers. Thank you for your time.